Hi, Dr. Robin here, and this is the first video in a two-part series about reaction mechanisms. In this video, I'm going to explain what reaction mechanisms are, and I'll introduce the idea of catalysts and intermediates. To understand reaction mechanisms, you need to think back to the collision theory of reactions. As a reminder, this says that molecules must collide at the right angle and with the right speed for a reaction to occur. If you want more in-depth coverage of that theory, I've dropped a link in the description below. So here I have a reaction in which oxygen, 2 hydrogen ions, and 2 electrons all combine to give 1 molecule of hydrogen peroxide. For that to work as written, you'd basically need all 5 of those things to collide at once. For simplicity, I've left out the 2 electrons. So in this cartoon, I just have the oxygen and the hydrogen ions moving around. As you can see, it's pretty rare for even 2 of the 3 molecules to collide. Getting 3 of them to collide is almost impossible. In general, what we're going to see happening in a reaction is that only 2 molecules will collide at a time, and then another 2, and so on. In the end, we'll end up with a multi-step process. A balanced chemical equation represents a net process. Do you remember the net ionic equations that you did earlier in Gen Chem? We will be using a similar process to create a net equation from different steps in a reaction mechanism. The difference is that in a reaction mechanism, steps have to happen in a particular order, and so a reaction mechanism will show this. Basically, what we're going to be doing is breaking everything down into steps, each of which involves only 1 or 2 reactants. We call each of these steps an elementary process. Again, each elementary process only has 1 or 2 reactants, so let's look at those 2 possibilities. If an elementary process has 2 reactants, what we call a bimolecular process, what is happening is that the 2 reactants are colliding to form new molecules. If there's only 1 reactant in our elementary process, what we have is a unimolecular process where the single reactant is going to break apart. One thing you may be asked to do is to determine whether a balanced equation represents an elementary process. To do this, remember that elementary processes only have 1 or 2 reactant molecules. So let's look at a couple of examples. You'll notice that in both of these reactions, there are 2 reactants. The first one has butane, C4H10, reacting with oxygen gas, O2, to form carbon dioxide and water. This is a simple combustion reaction that has 2 reactants, butane and oxygen. The second reaction has dinitrogen dioxide, N2O2, reacting with hydrogen gas to form dinitrogen monoxide and water. Again, 2 reactants. So with 2 reactants each, does that mean that they're both elementary processes? The answer is no. In the first reaction, there are 2 types of reactants, but there are more than 2 reactant molecules. There are 2 butane molecules and 13 oxygen gas molecules, so 15 molecules total. This is not an elementary process. In the second equation, again, we have 2 reactants, but do we have 2 reactant molecules? This time we do. We only have 1 molecule of N2O2 and 1 molecule of hydrogen, so that's 2 molecules total. So now let's go back and look at the balanced equation I showed you earlier. Is this an elementary process? Well, we have 5 total things reacting. 1 oxygen, 2 hydrogen ions, and 2 electrons. So this is not an elementary process. The way this reaction needs to happen then is through a series of elementary processes. Here they are. First, oxygen takes an extra electron to form superoxide. Second, superoxide reacts with a hydrogen ion to form the hydroperoxyl radical. Third, the hydroperoxyl radical picks up an extra electron to form the hydroperoxyl anion. And finally, the hydroperoxyl anion picks up a hydrogen ion to form hydrogen peroxide. So why do we even care about reaction mechanisms? Well, first of all, we can use reaction mechanisms to identify catalysts and intermediates. And secondly, we can use them to predict the reaction order of the kinetic rate law. Remember that when talking about kinetic rate laws, I told you that we can only determine the rate law experimentally. Although that's true, we can usually come up with a couple of possible reaction mechanisms for a given reaction, and we can use those reaction mechanisms to determine the possible rate laws for that reaction. In this video, I'm going to show you how to find catalysts and intermediates. We're going to talk about rate laws in the next video. So what are catalysts and intermediates? Basically, they're 2 types of chemical species that don't appear in the net reaction. We care about catalysts because they change reaction rates. With a catalyst, you start with it, and then you still have it at the end. A catalyst isn't used up over the course of the reaction. Another way of saying this is that a catalyst gets used in a reaction as a reactant, but it's also produced as a product. So you end up with the same amount that you started with. An intermediate is a substance that appears during a reaction. In other words, it's the product of an elementary process, but it also gets used up before the reaction finishes. So there won't be any left at the end. So let's talk about using reaction mechanisms, the set of elementary processes that make up a reaction, to find catalysts and intermediates in a reaction mechanism. The first step is to add elementary processes to get an overall reaction. And this process is just like the one we used to do net ionic reactions. The second step is to cancel out anything that appears on both sides to get the net reaction. Again, just like you did with net ionic reactions. Now, anything that cancels out will either be a catalyst or an intermediate. So now we have to determine which is which. A catalyst is something that you start with and end with. Remember, you always end with the same amount you started with. So a catalyst will appear first on the left or reactant side of an elementary process. And remember, you can think of an intermediate as a temporary product. So it always shows up for the first time on the product side of an elementary process. Usually it will then be a reactant in the next step of the reaction mechanism, which is how it gets used up. So let's look at an example reaction mechanism here. Here we have two elementary processes, and the first thing we have to do is add them together. So how we're going to do that, we'll take everything that appears on the reactant side of each of the elementary processes, and we're going to put them all together. And then next, we're going to take everything that appears on the product side of each of our elementary processes, and we're going to put all of those together. Step 2 is to cancel anything that appears on both sides of the equation. So looking here, we have NO2, one of those cancels out, and we have an NO3 on each side as well. What we're left with is what we call the net reaction. But now we want to identify catalysts and intermediates. Remember, those are going to be the things we canceled out, which in this case were an NO2 and an NO3. So catalysts are anything that cancels out that first appears on the reactant side. Do we have anything like that? Well, we do see here that NO2 first shows up in the reactants in the first step. So NO2 is a catalyst. Again, intermediates show up for the first time on the product side and are used up before the end of the reaction. NO3 appears in the products of the first step and the reactants of the second step. It doesn't appear in the final balanced equation, which means it has disappeared. NO3 is therefore an intermediate. To summarize what we've learned so far, reaction mechanisms explain how reactions occur, what collides with what, and in what order. Catalysts aid in these collisions, while intermediates are temporary products that occur as the reaction progresses. This video has been a brief introduction to some of the basic concepts involved in reaction mechanisms, and it probably leaves you wondering why we even care. Well, continue to the next video, linked below, and you may start to understand. I hope this was helpful, and I look forward to seeing you again soon.